Hello everyone, this is Mrs. Shaw, and today we're going to talk about geometric sequences. So a geometric sequence is a sequence that has a constant ratio. Well, here is an example of a geometric sequence. 2, 6, 18, 54. What's happening here? As we think, are we adding something to get from 2 to 6? If we added 4, are we going to get 18? No. Okay, so it's not like our arithmetic sequences that we've done. This one's a little different. We are going to have not a constant difference, but we are going to have, let's explain it here, this constant ratio. So in a sequence, the constant ratio is the number you multiply to go from one number to the next. So if we look up here at this example, is there a number we're multiplying to go from 2 to 6? Yes, it's times 3. Does that work every time? 6 times 3, 18? Yes, 54. So a geometric sequence, we have a constant ratio, which means it's the number we are going to be multiplying to go from one number to the next. So a recursive function is a function that helps you find a number in a sequence by knowing the number before it. You guys have been doing great at our recursive functions for our arithmetic sequences. So here's our example here. Here on this sequence right here, we go 8, 6, 4. We can see that our first number in the sequence, remember on arithmetic or on recursive functions, we state what the first number in the sequence is. F of 1 equals 8. And then we're going to state what's happening every time. So for any term in the sequence, it's equal to the term before it minus 2. We are subtracting 2 every time. This 2 was our constant difference. Well, now with the geometric sequence, we're going to have a constant ratio. It's the number we're multiplying every time. But with our recursive functions, we still are going to state our first term in the sequence. So our first term in this sequence right here is 2. Okay, our first term is 2. And what is happening every time? We are multiplying by 3. So remember, our recursive function is saying for any number in the sequence, it's equal to the number before it times our constant ratio. And in this case was 3. All right, here we have a new sequence. So we have 7, 42, 252. This is a geometric sequence. These numbers are getting bigger fast. So we know that we are going to be multiplying. What number am I going to multiply 7 by to get 42? If it's not something you can, if it's bigger numbers or your brain has not remembering your times tables or whatever, you can always take this second number in the sequence and divide it by the first number in the sequence. So 42 divided 7 is 6, and 6 is our constant ratio. Remember, our recursive functions are, we're going to state the first term in the sequence. The first term in this sequence is 7, and then we're going to state what is happening every time. And we do that by saying for any number in the sequence that is equal to the number before it in the sequence. And this time we are multiplying by our constant ratio, which in this case was 6. So our recursive functions are very similar for the geometric sequence as they are for the arithmetic, but we are having our constant ratio. That means we are multiplying by a number every time. Okay, so here is another sequence. Let's say you couldn't see what number you were multiplying by. And like I said, well, first of all, you might have a sequence and not even sure if it is arithmetic or geometric. And so you need to determine. Here we said we're looking for a ratio. So we do know we're looking at a geometric, but you know 5 plus 15 gives us 20, but we know 20 plus 15 will not give us 80. So we know that this will not be an arithmetic sequence. It is a geometric one. So what number are we multiplying by? 5 times 4 gives us 20. Well, let's see. Is that every time? 20 times 4 gives us 80. multiplied by 4, 320. So our constant ratio is 4. So our recursive function is we're stating what the first term in the sequence is. The first term in this sequence is 5. And remember that for a recursive function, we have to state what's happening every time as well. So for any number in the sequence, you're going to take the number before that and multiply it by our constant ratio, which is 4. So here's our recursive function for this sequence. Oh, and there we double checked ourselves when we got that correct. All right, maybe pause the video for a second and see if you can figure this one out. All right, this hopefully you've had time to do it. This one's a little bit different because we can see our numbers are going negative, positive, negative. Well, we're going to follow this the same way. We are looking for a constant ratio, so this is a geometric sequence. So we remember that in order to figure out what our constant ratio is, we can take any number in this sequence and divide it by the number in front of it. So we are going to take 16 and we're going to divide it by -2. Well, 16 divided by -2 is -8. So our constant ratio in this sequence is -8. Remember our recursive functions, we have to state two things. First, we state what the first number in the sequence is, and the first number in this sequence is -2. And then we're going to state what is happening. Well, for any number in this sequence, you're going to take the number in front of it. Whoops. And the number in front of an x would be, if your term is x, the number in front of that is going to be x minus 1. And we're going to multiply that by -8 because that is our constant ratio. Let's go up here and double check. I didn't do that before and we probably should have done that all along. We're going to check when you determine what your constant ratio is. Here we determined it was -8. We need to go up to our sequence and make sure we're correct. So we are going to you can use your calculator and do it quickly. You're going to take 16 and multiply that by -8. Do you get -128? Yes, you do. Then you're going to take -128, multiply that by -8. Do you get 1,024? Yes, you do. So that is a good thing to always check. And another thing, I have the answers right here as we all can double check as well. All right, let's try another one. Go ahead and pause the video and see how this one goes for you. All right. Well, this one is a little different because as you look at this and you look at 128, what am I going to multiply 128 by to get 64? Because remember, a constant ratio is something you're multiplying by every time. Well, when you look at this, you're like, well, it looks like you're dividing. 128 divided by 2 gives me 64. But what is another way to write that? Dividing by 2. What is something we can multiply? Well, one way to figure it out, if this is a geometric sequence, because we have our constant ratio here, it will work. We can just punch in your calculator, take any number in the sequence, and divide the number in front of it. So we can take 64, divide it by 128. Your calculator is going to say 0.5, but we like to use fractions. So instead of that decimal, we are going to write that as 1/2. And remember, if you get a different decimal on your calculator, you can always change that to a fraction by hitting math, enter, enter. So our constant ratio here is 1/2. Should we check that? Can we take another number in here? Let's take our 32, multiply it on your calculator by 1/2. And remember, so on your calculator, 32 times, you can change it to, you can put it in the fraction mode and do 1/2, and that will equal 16. But remember, you can also do 32, and you can use parentheses, 1 divide 2. And that will also get you 16. And you can see, so on your calculator, keep typing in 16 times 1/2 will give you 8. So our recursive function we're going to state our first term in the sequence, which is 128, and then we're going to also tell what's happening every time. For any number in the sequence, say I wanted to know the 10th number in the sequence, I need to take the 9th number, which would be x minus 1 if x was 10, and I'm going to multiply it by my constant ratio, which this time was 1/2. 1/2 was our constant ratio for this. All right, let's check again. Oh, here we go. This one, we're going to do one more example. I think this is our last one. 555. Whoa, what's happening here? We can see it's going down, so we are going to be multiplying by a fraction. So let's figure out what that is. We can take any number in the sequence. This time I'm going to take 5, and I'm going to divide it by the number in front of it. So I'm going to take 5, and I'm going to divide it by 50. What does that equal to? Well, that is 1/10. Okay? Your calculator might do 0.1, but you can always write it in fraction form. We like the fraction form. Well, let's double check. Is that right? Is my constant ratio 1/10? Remind me, how do we check again? Well, we take any number, we go through and see, can I take 500 and multiply it by 1/10? Do I get 50? Take 50 and multiply it by 1/10 and you get 5. Take 5 and multiply it by 1/10 and you get 1/2. So a way to type that on the calculator, remember, is, so say we're doing the second one, 50 times 1/10 to get 5. 50 times 1/10, you can use the fraction thing like that, or you can use, if you can use the fraction button, or just use parentheses with the divide. If you're going to do fractions, make sure you use parentheses. If you're going to use parentheses like that. All right. Okay, our first term on our recursive function, which we're practicing for this section of this unit, is we're going to state the first term in the sequence is 500. And you also need to state what is happening every time. So for any term in the sequence, that's equal to the term before it, and multiply that by our constant ratio. And there we have it, our recursive function of a geometric sequence.